Okay, just to recap what we discussed yesterday, we started with SQL coding, looking at several syntax, right, from creating tables, schema, displaying the data in the table, etc. I've shared the notepad with you in the Dropbox. If you have any issues in accessing those files or videos, just let me know. Find out alternative ways to do share the files. Okay, and the second, today's topic is going to be the HANA SQL syntax. We will be looking at. So far, we have seen database tables. Now we're going to see the database views. That's another component which we will be looking at in the schema. So let me log in. Okay, I logged in now. So in my catalog, excuse me, I've created several tables in yesterday's session. We have seen row tables and column tables. And we also seen several temporary tables, and we also seen how to insert the data into those tables, and we also imported the data from flat files. Okay, so we also have views in the schema. So these are the views which are created in the as a database artifact. So these are not information views which we're going to see in the modeling. These are all database views. If you're familiar with ABAP in SE11, you go into ABAP data dictionary and create a database view. So that is and then in the which in turn creates the database view in the database. So similarly, I can create the database view in the native HANA database directly. These are all the yesterday's session I'm closing. I'm opening a new session. The syntax for creating the database view is create view. Okay. So I'm creating a view here. My view name is orders_customer. It's going to be on my schema, and then I'm saying as as what are the fields which I would like to read from the table. See, I'm having two different tables to join and formulate a view. So the table one is sales orders, and the table 2 is customer. I don't think we have sales orders data loaded. I'm going to create that and load the data. Let me see why I have it here. So I'm using two different tables. One is the customer table and the other one is sales order table. I don't have sales order table. I will have to create now. So I'm going to create that from the import itself. For that, I am going to choose file, import, and then data from local file. It's slow. Okay. Header row exists and new scheme. See, I don't have an existing table here, so I will have to create a new table as part of the data upload process itself. So I'm going to choose my schema and I'm going to give the database table name as sales orders. Yeah, and say next. So the data mapping is all automatically done according to the source field source field data types, and then source I can choose what type of table it has to be created. I'm default it is column store here. I'm saying okay and then say finish. Importing flat file. You can see all the status messages in the bottom, what is running, progress, and what is the job log. And it looks like it is completed. I go into my schema table, or I don't, as we said yesterday, I can always say select star from sales orders, right? Let's see, we got some, yeah, we got some data. Okay. Now I'm going, I already have a table for customer. Let me see what data I have in customer. Oh, I think it is customers. Yeah, we got the customers. So what I'm going to do, I'm going to create a join between these two tables and then make a DB view on top of these two tables. I'm just wondering, the data type for customer is different. Yeah. So my table has taken the customer data type as numeric, so it is integer, and my other table has a data type of string. So I cannot do the proper join between a data type which is numeric and the other one with the integer. So I'm going to come back to this example. So basically, I will have to create a table which has got customer. I mean, both the joining fields both will be having the same data type. Okay. Let me run this. Now we got data. Now the customer is a string. Now I can perform the join. So I'm going to do a join between table one, and this is an alias. So I don't want to write the full name of the table. Instead, I wanted to use T1 as a reference to the field name. So that's the, instead of referencing full name of the table, I can use the alias and reference the field name towards that. Okay, so I have now um, let me see my field names from this table. So sales order number, a year, and I'm taking it. So let me just run this view statement. Okay, got it. So it's saying invalid column name in T2.customer ID. So my customer ID, I don't have customer ID in the customers table. I think it's the customers. Syntax error, what it's saying is line 30 column. Yeah, I have to end this bracket. Now it's created. So what is basically I'm doing is just creating a view from my first table is going to be my transaction table. I'm just giving an alias name to it and then doing an inner join to another master data table which is customer. Why do I do an inner join or whatever the other join? We'll talk about the joins in detail when we go into the select, but just for now understand that I'm making a join between two tables to get some of the fields from the customer table. So you can see I'm getting customer name and phone number, which are not in the customer sales order table from customer master data table. This is to complement my transaction data with some of the master data attributes. So I did that one. Now if I do the select star from this database view, I'm going to get the customer name and phone number filled in properly. So this view is actually joining two different tables and giving me the required columns from those two tables. Order number and year from first table, sorry, amount also. Customer name, I have joined customer number in the first table with the customer table and then got the customer name and phone number. So this is how you can build a database. You can have multiple tables. You can have inner join or left outer join, whatever the joins you may do, and then you may be arriving at a view, a database view. Okay, yeah, in my next example, I have got joining three tables. There's nothing big difference in the syntax. I'm just adding one more table to the join. Same, create view statement. This is my view name as what? As select all these fields and from this table as main table and then join the other customers table. And then we also got company code table. So currently I don't have company code table. I have to build that. So once I build that, it is going to be fine. So since I did not build it, I'm not really executing this one. It should be good. You need to build the company code table as I did just for the sales orders table now. And then this join will be working fine. Yeah. You can also use, this is a simple select came in, but it's not required to be here. You can, I'm just showing up the select which I made here. So the view is a result of this select only. So if I do this select in a display, so this is my select statement. This is what I am reading it. And I am just making a database view with the result of this select. That's it. So simple. I'm making a query and the result of that query is going to be stored as a view, database view. When I run my view, it is going to trigger this select and then project the values which are columns which are part of that select as a database view. Clear? So I can also create the database view with the fields defined in the list. Yeah, so this is a different syntax which we generally use in the ETL projects. So in many of the ETL projects which we work, you wanted to do the ETL data transformation in the database view, right? So without having any other external ETL tools, you can use this syntax. So let's say my source table has got um, 4 or 5 fields. There are 2 tables I'm joining. 4 fields from first table and 1 field from second table. And I also have one other field which is load time. I don't have this field in my sources, in my source table. So I wanted to derive that field. So it's a kind of a transformation. It could be complex logic. Instead of load time, you may have another field which could be a derivation with case statement or any other complex thing. So similarly, you may have 10 different fields which are completely new, specifically defined in the view. But how do you get the data for that is what you derive here, because the source tables cannot bring the data for those newly added field. So you can see the comment here, it's a derived field, not read from any of the 2 tables. So I'm transforming the data in by having another field. Then once I transform this data, if I read this table, this view data, and insert into another table, then I'm going to get the output with all these 6 fields together, all the fields of the view. So you understand, right? Some in between, so table 1 and table 1 and table 2, source table and target table, I'm creating a database view to derive some more columns, and then I'm reading that view and inserting entire data into that final target table. Is the general ETL scenario can be achieved using database views. Okay, let me do that. So you can see that order number, customer, this is the fields list of the view. So how do I populate those fields? Is this is select. I can also just pass year as a constant all the time, which is 2014. So what, it doesn't go into any of the tables, and it always go with the 2014 as the year value, and 2014 will be going into the second field all the time. Yeah, I don't know why I put the year here, because the order number is order number and second is customer. So instead of that, I should have year here. Okay, then if I run this one, it is going to create another view, and I can display the data in this view. Right, you got the year, amount, currency, name, and this one. So I explicitly define my columns. You can also see the result. The load time is current timestamp it has been taken. It's derived as a formula. You can say, you can have formulas, you can have case statement, and etc. The source of this call, the load time column, is derived here. Similarly, you can have 20 other fields when defining the view, which can be derived explicitly in the query execution. And then you can pass this result of the entire view into another target table, which is used for your further EDW enterprise reporting purpose. Okay. Yeah. Synonyms. So you got tables done. I got views done. In the views, we have seen 2 different syntax. Just take the database select statement output in as an output as a definition for view, or define your fields and then the reference those fields from select by using another select. If you don't do that, it's going to take whatever your select statement is bringing as a to formulate to define the view. If you say, it's going to match with your select field 1 to 1 in the order. Yeah. So those are the 2 examples I have here. And then synonyms. Synonyms, yes. In currently, we don't really use synonyms a lot. There is no big use of having synonym. It's like a shortcut to your table, and but in future in Web IDE for HANA, which is the replacement tool for Studio, synonyms are mandatory, and you cannot work without using synonyms. It is a basic requirement to know more about synonyms. How do you work in synonyms with, in Web IDE for HANA, which is in 2.0 SP02. So for Studio, I will just say this moment a basic introduction to synonyms, but we will see when we go into the Web IDE for HANA, how do we create the synonyms and what is the importance of having synonyms in detail. Okay, simple syntax, create synonym. Uh, for my employee details table. So that's it. If I go to my schema and refresh my schema, In the synonyms, I see this one, EMP synonym, just now I created. So I can just drag and drop here this synonym and select star from to see what it is doing. It's going to show me what exactly in EMP detail table. So it's referencing the EMP detail table locally. It's a shortcut to the EMP data table. It is not really required. You can directly write this EMP data table. You may ask, why do I need this to write? I can write directly. But in many of the procedures, you will have, there are different reasons for it. You don't create the table as you like this. You may your table will be created as part of your CDS object, or it could be your repository object from content. So there is a naming convention associated automatically when you create the table data dictionary objects from the content, like CDS or repository or your project name associated, and then it will come as a big, like a big string. So you cannot remember that string, and you cannot use that string all the places where you are going to use that particular table. So in that case, you create a synonym just like this for that, the big name of the table, and then you keep using that synonym wherever you wanted to use. So that is one purpose, and then second purpose is administrator purpose. There are some of the schemas which you don't want to get any access for updating it. You just need a read access. So they give a synonym on top of those schema and provide you the access to that schema, so that you can only access the schema from the synonym. That's for the administration purpose. These two are the basic prerequisites, requirements you go for a synonym. But in WebID for HANA, it's completely different. You must have synonym while working on, just because it is a schema-less development, you will need to have synonyms for each object you create. Okay, that's about synonyms. You also have public synonym. See, if I don't specify, it's going to be local. If I explicitly specify public synonym, it's going to create a synonym under the public. So and it can be, oops, what is that? Invalid schema name. Did I enter wrong? Let me type in. Okay, so I created a public synonym. It's going to be available right here, public synonyms. So it is not going to be specific to one schema, and it is going to be under a public synonym. Usually system tables, system annotations, and system tables stuff are going to be in the public synonym. Okay, and it can be accessed by anyone who has the access to this synonym privilege. There is a catalog, there is a privilege in to be defined, and then whoever has access to that, it's going to be available for them. So it's not going to be any one of the schema, it's going to be in public. Yeah, there's a little documentation about what is about and why do we need this, what is the requirement of having synonyms. Yeah, and the next thing is index creation. Yeah, you probably would have known multiple times about index creation. Every table, whatever it's a BAP or any of the systems, you will need to have a index for improving the performance and to read the data what is necessary for you when you're doing the reporting and etc. There is some information about what is index and what its pretty simple. Index is to directly point to the look for the record which you wanted to display in an effective way. So when you create the index, it automatically goes and picks up the records according to the index. It's like a book index. You have book. In the first page you got an index, you hit the index and you directly go to that particular page instead of going from page 1 to page 95. That's a simple example, but yeah, index in database terminology, you can see binary index is like, it's like a tree, right? So you got half of the values on one side, half of the values on the other side. It will branch from one to so when you are looking for one value, you don't need to read all the values, and then it separates the branching logic to the one side, and then it further breaks down the logic to the so every time it is going into this to the retrieve the data, the number of reads are going to be reduced. So that's primarily binary index is going to do. And CPP index for text analysis. So you probably see this. This is a text which I have. There is another text. So in order to compare these two texts, I don't think you will go into the detail every characteristics to be compared. If you see the first three characters, ERC and ERX, you can say that it is not the same. So that's what the CPP index does. So you don't need to go into the entire string. Wherever the first hit falls, then it automatically consider it is not same. So basically text kind of analysis and etc. you will use the CPP. It is not I will use it automatically. System takes for varchar and etc. It is going to take the CPP index by default. If you wanted to change that behavior, you can explicitly say that I wanted to have a different index for that. Okay. So I'm going to create a simple index here. You can see how it gets created. So I'm creating a simple column table with three columns. Done. That's my employee salary. I have ID with a tiny int, and then employee name varchar, and then salary int. So I'm now going to create an index on this one. Did I specify? No, I didn't specify anything. Invalid table name. I think it's the employee salary. I don't know why I made all these things. I have to review once all this, but it's so now the index is being created. I can go into my database graphical interface to see how the index has been created. My table is EMP salary. Open definition. So indexes. So an index is created. Index column is this name is index underscore EMP. Its type is index. So there is a there is an index created on this column, which is the employee name, and this is the column name. I don't specify unique, so that's why I did not create any unique index, and then it just created the column on top of this column. The further is partition we have already seen. So I mean, what does it mean? You can create the index in graphical interface also. So when you are making a table creation from the graphical interface, you can choose what type of index you are going to create, and then automatically it creates using graphical interface. Okay, so I got another syntax with unique CPP tree index, so that it's going to create explicit index. I don't think I have a table defined with employee index. I will have to create that. So I'm going to use the same syntax for this one as well. I'm going to create a new table first. I'm going to name that as EMP index. Same, not changed. Then I'm going to create another syntax for the unique CPP index. Okay, my index name is this one, and then I'm going to create, yeah, that's it. Yes. Invalid column name. Okay, it's EMP name. Done. I'm going to see how it looks like. Go to EMP index. Yeah. So this is what I have created, a unique index here. You can see that the checkbox is selected here. So what is the difference between unique and non-unique? See, with the unique, it is looking for the unique values on the indexing. It's basically it doesn't allow duplicates for creating the index on the data records. So if you say if you know it, you can specify unique. If you don't know it, you can just ignore the by default, which is non-unique. Okay. If you're sure that you wanted no duplicates allowed, you say that's a unique index you will create, and otherwise non-unique, which is by default. So this indexing, partitioning, is all very important things when you are working in a project, EDW project on the HANA native, even though it is not EDW project, or any other BW project also. Any of the database related activities, any of the database related improvements, the first place you will have to come to is going to be indexing, partitioning, and merging. These are the three different concepts which you always look at, loading and unloading also. We will come to that loading and unloading in the DML statement. So these are the different concepts which you will come to first as a first step to analyze the performance, to improve the performance of the queries which are running on HANA database tables. If you can do these all partitioning, indexing, and then etc. in an application, if you are using an ABAP, you know how to do it. If you're using BW, probably you would have known how to do this. You have a graphical interface to do those indexing in database, partitioning, etc. But in database, in native database, you don't have tools to do that. So you write SQL and do the, of course you have any UI to do that, like in this place, but if you, there are some restrictions with UI, but SQL is pretty much open and you don't have any control in writing the SQL doing these performance improvement options. Okay, any questions in there? No? Okay, let me jump to different topic. Database triggers. Yeah, so database trigger is it's another object you could see from the triggers. Yeah, so there are already system triggers. So trigger means you are telling the system to trigger certain action on certain other action. So one action taking place in database is going to trigger another action. So it's kind of a chain you may configure in the system. So in my example, I'm creating a column table, simple column table. As I said, I'm not going to type any syntax. Just it's easy. This table has got two columns. One is user and then log timestamp. And then what I'm saying, create a trigger, insert log, and and I'm running an execute function after insert on EMP for each row. So whenever you insert a record into the EMP table of my schema, it is going to execute this block. What is it doing? It's inserting an audit trail with the value of current user and current timestamp. So let's see. I'm going to create this trigger. Invalid table name. I don't know EMP. I have it. I have EMP details. Let me see. EMP detail. Sorry, I don't remember. Come on. So I'm going to drag it from the tables menu. EMP detail. Okay. So I'm giving a wrong table here. Right? That I'm giving a different schema here. So I can create now. So it's created. So whenever I create a record into the EMP data table, there is, this trigger is going to get executed, and then whatever is in between the begin and end is going to get, you may have 100 lines in between begin and end. Those 100 lines will get executed. So let's see, I'm going to insert record in the EMP day. I will let's see what is in the EMP detail table. So EMP ID, name and department. So I'm going to insert another record here. Insert into values. ID is 40 or just 100, I will say. And then name is Chris. And then department is going to be number 20. So I'm entering a new record here. Come on. Okay, the first one is number and then name and then department should be good. Number. What it says. I'm going to open a new screen. Max length violated. For okay, I think name I would have given small, so I'm just giving 4 letters now. Okay, so yeah, see that this is giving an error saying that user table is giving an error. So when I'm defining my log table in my previous session, I used varchar 10, right? So, and my user, what currently it is picking up a big one, so it couldn't do that. So I'm going to change it to 20. And then I drop it first. Drop table. You understand the issue is not in the first table, but it is even it's in the it's another table. So I'm dropping this table, okay, and creating again. Okay, done. Now I try to insert it. Again, expected row logs. It's still big. Sorry. let's say 40. Okay, come on, what is happening? What is my trigger doing? It's saying current user into my first one, and then current timestamp into the timestamp. It should be good with the current user. Why it's saying the current user issue? Instead of current user, let me create another thing. Okay, create trigger insert log 1 from this audit log. Instead of current user, I would say hard-coded value, my name. My objective is to test the functionality of the trigger, right? So let me try that. Done. And now I'm going to insert this there. Come on, what is going on? Locking field and reference table. Okay. So I understand this is a problem in the EMP data detail. It is actually, I have to give what is in the existing department. So it should go now. Yeah. So this is the EMP details table had some other problem. You remember, right? So when we declared the EMP table, we referenced foreign key and primary key table. So since 30 wasn't there in the primary key table, this was complaining. So 50 was there as a primary key in the EMP table, so the department table, so it allowed it. So that was the error which it was saying. So it should have allowed even the EMP details also. So that means if when I entered this one, my insert log and insert log 1 both should have got executed. Let's see. I got two triggers right now, and one is select star from EMPD. What is that? Insert log 1. Sorry. Audit. So I got two logs just because I have two triggers. One is for the insert log 1, and I also have insert log. So it executed these two triggers and inserted the timestamp into inserted the timestamp into audit table, right? Yeah, that's about the um, database trigger. So you can have all update, delete, whatever you wanted to do in this begin and end. You can just try the delete also. I'm doing an insert log 2. This is a new trigger, and after insert in every row in detail, I'm going to say delete everything just for checking. Delete or truncate. I'm going to truncate everything. No values. That's it. Let me execute this. Come on, this is already always having an issue with the Express Edition in HANA. Incorrect syntax near Surumpali line 7. truncate table. Okay, sorry. Only DML is allowed, not the data definition. So truncate is data definition language. So that means you're completely. You can either use uh, update, insert, one of these actions in as a trigger. You cannot create a table or you cannot truncate a table when you are with the sequence. Sorry, with the triggers. Okay, so that's not yet not allowed in the HANA SQL. You can see that as the error. Okay, so that's about this, and then simple thing is comment table. It's very easy. So if you wanted to give some comments, you can say you can describe the comments on the table. So this is going to be a table. I'm creating it. I wanted to comment on the table. See, let's say I'm going to execute this one. So this is for user understanding. Somebody who is coming to see this table can understand very well if I provide the comment. So I'm saying create on comment on table, EMP comments is EMP. So this is the comments you will get when you open this table. So similarly, you can provide a comment on columns also. Each column you can provide the comments, right? So to explain, it's not the description, it is the comment, some kind of text you can put it in there to the developer to make it understandable in a better way. And then sequences. Sequence, yeah, number ranges in your SAP system. If it is an SAP application, you have a generated number range, right? Similarly, in database, you got sequence, which is to increase the value or to maintain the sequence of it. Okay, just you see that next value is a function so that you can get the next value on it. Invalid sequence. Okay, I have to define my sequence first. Create sequence. Or the easy way is to do this way. Go to the sequences and say create new sequence. So sequence name, EMP sequence, and then it is starting with 1 and increment by 1, minimum value 1 and maximum value I say 100 and cycle it. So whenever there is 100 it again starts with reset query, we'll say it later. Just that's it, and then I'm going to save it. Where do I save it? I lost the saving button. I'm going into the middle. Come on. My window has some problem to do the, I can try it in a new window. Yeah, that's easy. I mean, you can just create the sequence, new sequence. EMP sequence. Maximum value 100. And then cycle it. Yeah, for some reason it is not enabled here. Sometimes my menu is not getting enabled. Otherwise you should see this execute button here, right here. Okay, so now it is executed. It created a statement. So this is the create sequence statement. You can run this statement in SQL, which is going to create a sequence. I mean, it's up to you. How do you do it? Whether using a graphical or using a sequence. So I'm going to run a create sequence, employee select 1, increment by 1, start with 1, minimum value 1, maximum 1, and cycle 1. This is going to create another sequence. Yeah, this, I have to reset my settings. Sorry, I will do that. So every time I have this problem, in case if I don't find it, what I should do is just select it and execute it. Okay, now another sequence created. I can see the another sequence. Okay, so you will increment the sequences like that. When you wanted to increase the next number and data analytical requirements, you do this one. Okay, that's about the sequence. And then, yeah, that's the end of the database artifact creation. That's the DDL. Oh, so we got another couple of DDLs which are alter table. It's simple. So when you wanted to add the table column name to the table, you can just say alter table and this syntax. It is going to add new column to the table. And you can similarly you can drop the table, or you can update the table. Sorry, drop a column from a table, and you can also do update, change the column properties in a table. For no need to delete the data in the table, for removing or even for any adding it, etc. When you add it, by default it is going to add in the last as a last column in the end of the table. And then you can update the properties of the table by using the alter. So alter is commonly you use, and drop is, you know, dropping the table completely. Delete is different, drop is different. Drop means I'm completely taking out the table from the existence. So if I say restrict, if it gives an error when there are any dependencies. If you don't give restrict and say cascade, it deletes all the dependents objects also. Okay, rename is just to rename the column. You can also rename the table according to your new column name and new table name. Simple. Okay, then the DML. That's pretty much more important thing is select and update are going to be very important when you're writing the procedures, when you're making the data selections, querying, and etc. These three, actually mainly two, but insert is just not a big deal. These two they play a major role in your scripting. So we're going to see the update and select statement in detail in the next session. I think I'm good with this today's session, and if you have any questions, you can start asking now. So just we discussed all the DDL syntaxes: table creation, view creation, sequence creation, synonyms creation, trigger creation, and etc. As I said, we will come back to column views and EPM, these things in the when we go into the modeling part. During modeling part, we will identify how these objects going to be created. And we have index also we have seen, binary and bitmap, CP, and then actually CPP. And procedures and functions we are going to see, we're going to start tomorrow, but they will take 3 days at least. So if you have any questions in indexing, sequencing, synonyms, tables, triggers, and views, you can ask now. All right. If you haven't got a chance to ask, you may ask in an email. I will be replying to that email. So I'm going to share this notepad. You can do the practice with the yeah. There are some syntax issues you probably would have noticed when I'm typing in. I think when you follow the video, you will be able to catch those errors and then fix the code in the notepad. They are very simple name errors, etc. Okay, that's it. I'm stopping the session.